Okay. So blood can be divided into two basic components, which are plasma and formed elements, where formed elements are the blood cells. Let's chat about plasma first. So in the plasma, you can identify two components. It is serum and coagulation factors. As you can imagine, coagulation factors are responsible for the clot formation. Serum contains things like albumin, which is the main osmotic component, the blood, and different globulin proteins transporting, like alpha globulin, beta globulins, gamma globulins, which are immune proteins, respiratory gases, nutrients, wastes, hormones, all of it is in the blood. Good? Right, blood cells. So we've got red blood cells. And formed elements are all cells. Red blood cells, which participate in oxygen and CO2 transport. Okay. We've got white blood cells. Okay, which provide immune protection. We're going to talk about them a little bit more. And we've got platelets. Blood. Prevention of bleeding. Does that make sense? Okay, so let's talk about white blood cells a little bit more. White blood cells can be broadly divided into two groups. One group is called granulocytes, and another is agranulocytes. The difference between the two is that granulocytes contain cytoplasmic granules, and agranulocytes do not contain cytoplasmic granules. Granulocytes, even further, can be divided into several major categories. First category is neutrophils, okay, which provide protection mainly against bacteria. Okay, they're called neutrophils because they can be stained by either acidic or basic dyes. Then we have eosinophils, which provide protection against various eukaryotes, like helminths and protozoa and fungi. They also participate in allergic responses. And lastly, basophils, which are crucial for inflammation and allergic responses. Okay. Now, I want to highlight that these neutrophils, eosinophils, basophils, basically all cells that we're going to be talking about are found in the circulation. Now, under the basophils, I'm going to put another category of cells. I'm going to put them parentheses. They do exist. Mast cells, same function as basophils, but they are in tissues. Okay? Basically, those are basophils, but in tissues. Now, agranulocytes. Two main categories are, first one is monocytes. And monocytes, they actually are immature cells. They differentiate into macrophages. I'm going to put the macrophages. Okay. So macrophages. Macrophages, as you can guess from the name, are big eaters. They eat other cells, debris, pathogens, whatnot. Does that make sense? That's their function. They are actual function. And another type of agranulocytes are lymphocytes. Okay. And here, three subtypes are NK cells. Okay. T cells and B cells. So what do they do? NK cells and T cells, they are antiviral. Strongly. And they also are indispensable for fighting cancer. Does that make sense? B cells produce antibodies. So far, that make sense here? So a couple of things about this stuff. So practically these ones, including NK cells, are components of innate immune response. Okay, innate immunity. And these components of adaptive immunity. Okay, so what's the difference? Neutrophils basically indiscriminately destroy bacteria. Does that make sense? NK cells will indiscriminately destroy virus-infected cells. When we come down to T cells, for instance, if you have T cells that are formed that are targeted against influenza, they will recognize only influenza-infected cells, not only all. Does that make sense? Good? Okay. Now, I want to highlight a couple of things here. No, don't highlight those because it's terrible. Just don't roll terrible. I know it. So these are cells of lymphoid lineage. And all these are cells only. So these ones. That is myeloid. I know that it sounds like Greek, but it is. So lymphoid lineage, lymphocytes, all three. Everything else is myeloid. I'll explain now. Look here. We call this process hematopoiesis. Okay, well, let's call it even leukopoiesis. Okay. So you have bone marrow stem cells. In bone marrow. Now, this bone marrow stem cells can differentiate into myeloid stem cells, or I'm going to actually this I'm going to call it myeloid stem cells, or lymphoid stem cells. And look at this. From here, myeloid stem cells will differentiate into monocytes, basophils, eosinophils, all that kind of stuff. That makes sense? Then lymphoid stem cells will differentiate into lymphocytes. Does that make sense? That's just really like terminological. Okay, we good? Like this. Now, how are platelets generated? And we're actually going to get into the entire hemopoiesis thing. Okay, so how are platelets generated? Bone marrow stem cells. And those are steps that you need to know, not more than that. Megakaryocytes. And megakaryocytes differentiate into platelets. Okay? Now, what about red blood cells? Bone marrow stem cells. I am not asking the intermediates, like reticulocytes. I don't really care. I want you to understand this. I'll explain more. So, bone marrow stem cells, after many, many steps, develop into the red blood cells. What I want you to understand are the stimuli. So the main stimulus for differentiation is a hormone called erythropoietin. That is produced by kidneys. What can stimulate production of erythropoietin? Basically two things. I'm talking about otherwise healthy person. One, low number of red blood cells. Say hemorrhage, bleed. And two, hypoxia. Does that make sense to you? So when you are hypoxic, or when you are losing blood, that stimulates erythropoietin. Erythropoietin in turn stimulates red blood cells production. Okay? Good? If anyone wants to take a picture of this, take it now because I'm going to kill someone.